Okay, the 12 basic functions. The attributes that we learned from 1.2 have to do with things like end behavior. We also had asymptotes, vertical and horizontal. We also had symmetry, where we are looking at even, odd, or neither. About the y-axis, the origin, and the x-axis. We also talked about extrema, and extrema had to do with things like max and min. We also looked at boundedness. We also looked at increasing and decreasing. We also looked at continuity. Continuity, there was 3 types of discontinuity. We look at range, and we looked at the domain. Those are the attributes of functions. Now, we also said that on the handout that we did last week, we did all 12 of these, and they are on page 102, so you need to know this for your quiz on Friday. Basically, what the graph is, what are some of the attributes from above, whether they're even or odd, things like that. On this one, 9 of the functions have the set of all real numbers. Out of those 12 basic functions, which do not have a set of all real numbers? Well, the first one is 1 over x. We can't have 0. The second one that I can think of is the natural log of x. Can't have 0, and it can't have negatives. And the other one is y equals the square root of x, because you can't have negatives under the square root. One of the functions has domain the set of all reals except 0. Which function is it? That would be y equals 1 over x. And why isn't the 0 in its domain? Because we can't have 0 in the denominator. No 0 in denominator. Now, out of these other 2 functions, we have no negative numbers in the domain. Of these 2, which one is defined at 0? All right, so these 2 have no negatives. You can't have a negative under your log, and you can't have a negative under your square root. The only one that's defined at 0 is this one, because you can have the square root of 0. That's true. You cannot have a natural log of 0. Only 2 of the 12 functions have a point of discontinuity. Are these points in the domain of the function? Now, here is the greatest integer function, and that particular one looks like this. And so we have points of discontinuity. And we also have the function y equals 1 over x, which looks like this function. And the asymptotes happen to be the x and y axis. Now, are these points in the domain of the function? Now, the 0 is not in the domain, no. Now, if I look here, I'm allowed to have all these x values. So yes, it's just that I'm only allowed to have integers for the y. Now, only 3 of the 12 basic functions are bounded above and below. Now, those happen to be y equals sine x, and you'll get to know these better, y equals cosine x, and the logistics function, y equals 1 over 1 plus e to the negative x. Now, of the 3 of the 12 basic functions are even. Which ones are they? Well, y equals x squared looks like this. Y equals the absolute value of x, which looks like this. And the other even function is y equals cosine x, which happens to look like that graph. All right, given this function, we need to answer this question. Now, I know that this is a parabola, and you should too. So if I look at it without a calculator, I shifted to the right 2, and this is what my graph should look like. If I do that, this is a 2. On what interval is the function increasing? It's increasing from 2 to infinity. On what interval is this decreasing? It's decreasing from negative infinity to 2. Now, if I look at symmetry, it is not symmetrical about the y-axis. It is not symmetrical about the x, nor is it symmetrical about the origin. So I'm going to say that it's neither. It's not odd or even. It is symmetrical about the x equals 2, but that is not what determines odd or even. Does the function have extrema? Yes, it does, and it happens to be at 2, 0, and it is a minimum, an absolute minimum. There is nothing else lower than that point. How does the graph relate to this one? It shifted right 2. So here we have a piecewise function, and we're going to draw it. If you recall, this is a line that goes up 1 over 1, up 1 over 1, and it goes this direction. We only want the x's that are 0 and bigger, so it's only going to be this part of the line. The second part of this is negative x, which again goes through 0, goes up 1 over 1, up 1 over 1, up 1 over 1, and we only want those x's that are negative. So when we put it together, which of those of the 12 basic functions does it look like? It looks like the absolute value function. Alright, here is your function. And what we have here is that we have two of, it's a piecewise function, or what we need to do is make it into a piecewise function. This looks like the square root, so I'm going to write f of x equals the square root function, and that looks like that it would happen when x is greater than or equal to 0. And then I'm going to look and say this one here looks like a parabola, so if I do negative 2 and I square it, do I get a 4? I do, so I've got this one, and I'm going to look at those less than 0. Now I don't include the 0, because if I included the 0, then it wouldn't be a function. So I've got it just like this. And it doesn't matter which one you do. Is it continuous? Yes, it is continuous. Now what they're asking us in this example is to look at the natural log function, and it looks like this. And it's asking us if we actually are approaching a horizontal asymptote. And if you keep looking at your table and it keeps going up and it keeps going up, the answer would be no, it doesn't. You could zoom in, it just increases very slowly. It is not reaching a horizontal asymptote. Now if I wanted to, I can give a complete analysis on this basic function, but all you need to do is to see the handout that we gave you on section 1.3. And one of your groups in class analyzed this, so I'm not going to go through it on this video.